afternoon. This is the video to help you prepare for Skill Test 4. Skill Test 4 will cover systems of equations and systems of inequalities from last test, as well as new topics, matrix operations, matrix applications, arithmetic sequences and series, and geometric sequences and series. Alright, so let's start with matrix operations. Matrix operations are addition, subtraction, two kinds of multiplication and division, and inverses, the equivalent of division. I'm going to do this mostly by example, so I'm going to give two matrices. A matrix we'll call A, which will be 1, 2, negative 3, 0, and a matrix called B, which we'll say is 2, 3, negative 1, negative 2. And I'm going to show you the various operations with these. First of all, you size the matrices by row by columns. This is 2 rows by 2 columns. And this is also 2 rows, 1, 2, by 2 columns, 1, 2. In order to add them, these matrices have to be exactly the same size, which they are. Okay, so let me start with addition, and I'll do what is called scalar multiplication at the same time. So I'm going to do 2a plus b. Now, first of all, 2a means multiply 2 times every number inside the matrix A. So 2a becomes 2 times a, which is 2, 4, 2 times 1, 2 times 2, 2 times 3, negative 6, and 2 times 0, 0. And then we're going to add that to b. 2, 3, negative 1, negative 2. Now, how you add matrices is that you add their corresponding elements. In other words, A11 gets added to B11, A12 gets added to B12, etc. So this matrix becomes 2 plus 2, 4 plus 3, negative 6 plus negative 1, and finally 0 plus negative 2. Or, in other words, 4, 7, negative 7, negative 2. All right, that's addition and scalar multiplication. Again, scalar multiplication, you just distribute the number through. Addition or subtraction, you just add or subtract the corresponding elements. All right, now we're going to do matrix multiplication. I'm going to use that with A and B as well. When you matrix multiply, these two inside numbers here, in other words, the columns of A and the rows of B, have to be equal. Otherwise, you can't multiply. The outside numbers, this 2 and this 2, tell you the outcome size. In other words, if I multiply A, the matrix, times B, the matrix, I will get an outside number 2 by 2. So this is the output size, 2 by 2 in this case. Okay, so let me show you how you do this. I'm going to write that down. 1, 2, rewrite the matrices down. A is 1, 2, negative 3, 0. B is 2, 3, negative 1, negative 2. Okay, the basic way you multiply matrices, the basic rule is row times column. And then you do what's called a dot product, which means multiply the corresponding terms and then add them. So, for example, if I want to find the first element of my 2 by 2 matrix, that's going to be my output, I take 1 times 2, first element times first element. First I want to take this row times this column here. So I'm going to go 1 times 2, first row number times first column number, plus second row number, 2, times second column number, negative 1. And that will give me 2 plus negative 2, or 0. All right, that's the first element. Now to get the second element over here, I'm going to take row 1 and multiply by column 2. Again, row times column. So it's 1 times 3, first element times first element, plus second element times second element, 2 times negative 2. Or in other words, 3 minus 4, or negative 1. Now we go to the second row. So I go negative 3, 0, times 2, negative 1, and I go negative 3 times 2, first element times first element, plus second element times second element. And that gives you -6 plus 0, or -6. And then finally, the last element comes from second row times second column. -3 times 3 plus 0 times -2, or -9. And there is my output. 0, -1, -6, -9. All right, I'm going to give one more example. A little more extreme example. I'm going to make two more matrices, C and D. C is going to be a matrix, 1, 2, 3, and D will be a matrix, column matrix, 1. Let's just make it 1, 2. I'll make it -1, 2, and 0. Okay, now this is a 1 row by 3 column matrix, and this is a 3 column by 1 row matrix, which means that these two are the same as they're supposed to be, and the output is simply going to be a 1 by 1 matrix. In other words, one number inside a matrix. So let me multiply that again, row times column, because there's only one row and one column this time. 1 times -1 is -1, plus 2 times 2, plus 3 times 0. Again, first times first, second times second, third times third, and add them up. And that number is -1 plus 4, 3 plus 0, or 3, in a matrix. All right, now we're going to do inverses. I'm going to use these same matrices. So first of all, inverses is kind of the matrix equivalent of division. And you can only invert square matrices. And I'm going to do a general rule first, and then I'll apply it to these two matrices as examples. So I'm going to take the inverse of a matrix, let's say A inverse. Well, let's start with the matrix generally first. A, which is an element A, B, C, D. If I want to do the inverse, it is 1 divided by one diagonal times the other, one diagonal multiplied together minus the other diagonal multiplied together, which is AD minus BC. This is just a number, it'll be a fraction. If it's 0, you can't find an inverse. And then you multiply it by this matrix rearranged a bit. You swap the D and the A, so it becomes DA was AD. And then you change the signs, but do not swap the other terms, like so. So ABCD becomes D negative B negative CA. Flip these two, make these two negative. Or change the sign of them. Okay, so let me apply that to our matrices up here, one at a time. So we'll start with A inverse in my example. I will do 1 divided by 1 times 0, which is 0, minus B times C, 2 times -3. That number is 1/6. Now I take my matrix and I flip this diagonal. 1, 0 becomes 0, 1, and I change the signs of these. 2, -3 becomes -2, positive 3. And if I want to write the final answer, I'm going to leave the 6th outside. It's just a number. 0, -2, 3, 1. And that's A inverse. Now, what is an inverse? Inverse is something, when you multiply it by the original, you get the matrix equivalent of 1, which is the identity. All right, let me do the same thing for B. Also, if I do an inverse, B times B inverse should also be to I. All right, so B inverse is 1 divided by 2 times -2, which is -4, minus 3 times -1, which is -3. So -4 minus -3, which is the same thing as +3, or 1 over -1, times, in this case, flip these two, -2 and 2, change the sign of these, -3 and -3 and +1. And that's it, except I have a little simplification. This part actually is -1, so I can actually distribute it through. Normally I just leave it on the outside. So I get 2, 3, -1, -2. So I take this matrix and I multiply it by that, which strangely is itself. Let me just check that to make sure, because that seems a bit odd. I should get 1, 0, 0, 1. row times column. 4 minus 3, 1. 6 minus 6, 0. Negative 2 plus 2, 0. Negative 3 plus 4, 1. Wow, that's just coincidence. Anyway, it does work, and therefore the inverse was itself. The matrix, its inverse was itself. Okay, that won't normally happen. Now we're going to move on to matrix applications. And the applications I'm going to deal with are solving matrices by row reduction and solving matrices by inverses. And I'm going to use a single set equation for both of these, so I'll write it up here. 2x plus 3y equals 12, and x minus 4y equals negative 5. I'm going to solve it both ways. Okay, so first way to solve it is by row reduction. So what I'm going to do is I'm going to convert this matrix here, or sorry, these two equations to a matrix by just taking their coefficients, 2, 3, and the number across the way, 12, 1, negative 4, and negative 5. And what I'm going to do is convert this representation of the equations to 1, 0, 0, 1, and then the answers will be over here. And I'm going to do that through a series of steps by reducing first the 1 to 0, then this to 1, then the 3 to 0, and then the 2 to 1. And I'm going to go, in other words, I'm going to start here and I'm going to go this way. Start here and go this way. All right, let's start with making the 1, 0. So think about how you do it with elimination of systems. If I want to eliminate x up here, I'd multiply the second equation by negative 2 and add it to the first. I'm going to do the same thing. I'm going to multiply the second equation by negative 2, which gives me negative 2, 8, and 10. And note that I'm writing them down below here rather than change any of the lines in the matrix itself. And then I'm going to add that to the top matrix, and I get 2 plus negative 2. I'm going to put it in the second row where the 1 is 0. 3 plus 8 is 11, and 12 plus 10 is 22. And I'm going to leave the top equation the same. All right, now this says, the equivalent, if I were to go back to the system, says 11y is 22. So to solve that, I'm just going to divide by 11. And that gives me 1 and 2. By the way, on the test, write every one of these steps so I can see what you're doing. All right, there we go. And that means that, by the way, y is 2. Now I'm going to get rid of this 3. To do that, I multiply the second equation by negative 3. And that gives me 0, negative 3, negative 6, and I'm going to add it to the top equation. And that finally will give me 2, 0, negative 3 plus 3, negative 6 plus 12 is 6, and the bottom equation I'm going to leave the same. Again, note that I don't replace that with that. I could, but then I just have to undo it, the negative 3 again. And then finally this says 2x is 6, so I'm going to divide the top by 2, and that gives me my final matrix, which is 1, 0, 3, 0, 1, 2. In other words, x is 3, y is 2, which I can see works up there also. 2 times 3 is 6, plus 3 times 2 is 6, gives you 12, and 3 minus 4 times 2, or 3 minus 8, equals negative 5. So there's my answer. All right, now we're going to solve that same set of equations, so I'm not going to erase it, by inverses. So we're going to convert this to a slightly different equation. Different way of writing it, rather. 2, 3, 1, negative 4. That's the same thing I did last time. This time I'm going to close the matrix and call that multiplied by xy equals 12, negative 5. This is called B. This is called A. I will call this x with a bar across it. It's also just xy. And if I want to find B, or sorry, if I want to find x, I just multiply both sides by A inverse. And I get x equals A inverse B. That's my general equation. In other words, all I have to do is invert the 2, negative 4, or the 2, 3, and 1, negative 4, and multiply it by the 12, negative 5. So that's what I'm going to do. A inverse is 1 over 2 times negative 4, or negative 8, minus 3 times 1, in other words, negative 1/11, times, flip these two, A and D, change the sign of B and C, And that's it. And then I'm going to multiply that ultimately by, I'll write this down first, negative 1, 11, negative 4, negative 3, negative 1, 2. I'm now going to multiply this by b, which is 12, negative 5. So I'm going to leave the low and 11th out until the end. Times 12, negative 5. This is again matrix multiplication. A 2 by 2 by a 2 by 1 will give me another 2 by 1 with my 11th out front. And I go negative 4 times 12 is negative 48. Negative 3 times negative 5 is positive 15. That's my first number. And the second one is negative 12 plus negative 10. Or in other words, negative 1/11 of negative 33, negative 22, which is 33 divided by 11, 3, 22 divided by 11, 2. In other words, 3, 2. Same answer I had before. So again, how you solve matrix applications by inverses. Find the inverse. I'll put in a matrix first. Find the inverse, which is what I did right here. And then multiply it by b, which is the numbers on the right side of the equation. And you'll get the same answer you do by row reduction. All right, that's all I'm going to do for matrix applications. We are now going to do sequences and series, and I'll start with arithmetic. And there's going to be a few equations on this, which you should make sure you write down. Sequences and series. We'll start with sequences. So an arithmetic sequence, I'll give you a couple examples. 1, 5, 9, 13. An arithmetic sequence, you are going up by a fixed number or down by a fixed number, which in this case is positive 4. And we'll call that number D, or the common difference. And in this case it's 4. All right, so what did we do in arithmetic sequences and series? First of all, you should be able to generate the 10th number in the arithmetic sequence, or the 50th or the 20th. And the way you do that is with formulae. Either the explicit formula for an arithmetic sequence, or the recursive formula for an arithmetic sequence. So the explicit one is a sub n equals a sub 1 plus, in parentheses, n minus 1 times d, where n is the number in the term, or term, or number in the sequence. D is the common difference, what we got here. A1 is the first term. Okay, and then the recursive formula says I start at whatever A1 is, and make sure you write that as part of the equation. And then the subsequent terms are the previous term plus the common difference, or D. All right, those are the two equations you need for sequences. So let me do that for this one. I'm going to estimate, I'm going to tell you, not estimate, I'm going to give you what A10 is, or calculate what A10 is. So A10 would be A1, let's do AN first. A sub n is A1, which is 1, plus n minus 1 times 4, the common difference. So now if I want A10, I just write 1 plus 10 minus 1, or 9, times 4. 9 times 4 is 36, plus 1 is 37, and that gives me the 10th term. This is the general explicit equation for this. This is the one for just the 10th term. Okay, the recursive formula. Let me circle this. This is the actual equation I want, and this is the number for A10. The recursive formula is A1 is, in this case, 1, where I'm starting, and A sub n equals A sub n minus 1 plus 4, and that's my recursive formula. Now, if I want the 10th term, I have to write all the terms out, which I will do. 1, and then I put it in here. A2 equals A1 plus 4, so I add 4 and get 5. A3 is A2 plus 4, so I take 5 and add 4, etc. until, and I keep adding 4, 3, 4, 5, 6, 7, 8, 9, 10th term right there. Now notice in the recursive formula, I actually had to write every term to get to the 10th term. In the explicit term, you can get the number explicitly by just using the equation directly. All right, that's the sequence part of arithmetic sequence and series. Now let me do the series part. I'm leave that one up there. So a series means you're adding them up. So this is a sequence. The subsequent, or the corresponding series, is 1 plus 5 plus 9 plus 13 plus, let's say, plus 37. And that's a series. And that will just be equal to a number. Now the equation for finding the value of the series, which I'll call S sub n, which is also the sum from n equals 1 to n, say k equals 1 to n, or I sometimes used, of a sub n, in other words, you're adding them up from 1 to n, is equal to a sub 1 plus a sub n divided by 2 times n. In other words, I take the first term, I take, if I'm finding the sum of the first 10 terms, the 10th term, divide by 2, and multiply by the 10th, or by 10, n. Okay, you can also, if I wanted to put instead of putting a sub n there, put the explicit formula for a sub n, and that will give you n over 2, 2a1 plus n minus 1 d, just by substituting an as a1 plus n minus 1 d. All right, I'm going to use it for this. Let me demonstrate it for this equation. If I say I want to find the sum of the first 10 terms, which I know goes up to 37 because I just calculated it before, I get 10 times a1 is 1, an is 37 divided by 2, or 38 divided by 2 is 19 times 10, or 190. And there we go. Now, if I don't happen to have n, I had n in this case because I calculated an before. Let's say I don't have n. Don't have n. If it's a small number of them, I would actually just write them all out and count them. So there's two possibilities. Count them to get n, to know that it's 10. Like up here, I didn't say it was 10. I just happen to know that 37 was the 10th one. But I could write them all out and go 17 plus 21 plus 25 plus 29 plus 33 plus 37, and then just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms. The other way I can use it, is to use the explicit formula. And let me give you an example of that. So I'm going to erase these back here and show you how I would do that to find that this is 10. The 37 is 10th term. So I can use my explicit formula, which is an equals a1, which is 1, plus n minus 1 times 4. And if I put in an, my last term, 37, I can solve for n. So subtract 1, I get 36 equals 4n minus 4, add 4, and get 40, divide by 4, and finally n is 10. So again, if it's a short number, I would just count them out. If it's a large number, like this is not 37, for example, but like it's, I don't know, 437, I would do it this way. Again, write the explicit formula, put the last term here, and solve for n, which will tell you what the term number is of the last term. All right, that's it for arithmetic. Now we're going to do geometric. One other thing on arithmetic, which I should have said, which is arithmetic series only have value if they are finite. They have to be finite. If they're infinite, then say for you have, this is not geometric, but if you had that previous thing, 1 plus 5 plus 9 plus 13, and it goes on forever, if it goes on forever, it's going to be infinity because you're adding numbers forever. So it has to be finite. That is not true with geometric. Okay, let me do this with an example again. I'll just go through the same stuff I did with arithmetic. Let's do 8, 4, let's make it a little different, put negative, 8, negative 4, 2, negative 1, etc. So in this case, this is a geometric sequence, which means you are multiplying something by a common number. in this case, negative 1/2. So 8 times negative 1/2 is negative 4. Negative 4 times negative 1/2 is 2. 2 times negative 1/2 is negative 1. That is called R, which is the common ratio. In this case, negative 1/2. All right, now I'm going to give you the explicit and recursive formulae. So let's start with, just like we did in the last case, explicit and recursive for a geometric. Explicit is a sub n, again you just have to know what term you're looking for, equals a1 r to the n minus 1. Recursive is a sub 1 equals whatever it is, where are you starting, and each subsequent term is equal to the prior term times r. Okay, let me give you, we'll use this now with this example to, for example, let's give the, first I'll give you the equation, and then I'll give, say, not the 10th term, because that's going to be really tiny. Maybe the 6th term, which I know what it is actually. I could just count it, it'd be 1/2, negative 1/4. But I'll use the equations for it to show how you get that. So first of all, my explicit formula for this example is a sub n equals a sub 1, which is 8. R is negative 1/2, make sure you put it in parentheses, to the n minus 1 power, and that's my explicit formula. The recursive would be a1 equals 8, and a sub n equals a sub n minus 1 times, and again in parentheses, negative 1/2. There we go, there's my example. All right, I'm going to calculate a10 in both cases, or not a10, we're going to do a6, right? a10 would be really tiny. a6 will be 8, negative 1/2 to the 6, to the n minus 1, or 5th power. And that's still kind of a mess, but I can do it. Negative 1 to the 5th is negative 1/32. 1 over 2 to the 5th, and then it's negative, times 8. That is negative 8 over 32, or negative 1/4. There we go, using the equation. Now I'm going to use the recursive. a1 is 8. So a2 must be a1 times negative 1/2, or negative 4. And then a3 must be a2, which is negative 4 times negative 1/2, or 2. I'm just writing the four first terms just like up here again using the equation. Next one is negative 1, keep multiplying by negative 1/2. Next one's 1/2. And the next one's negative 1/4. And there's my answer, same answer. Just two different equations or methods of equations that will give you the same answers. All right, if you have to find n again, just like last time, you can plug it, you can use this equation and put the last term here and solve for n, or you can just count them out again. I could just basically keep going with this thing. Negative 1/4, 1/8, negative 1/16, etc., until I get to the number that I'm actually trying to find, and that will tell me n. All right, let's do series now for geometric. We'll do it with this equation ultimately, but let me give you the equation first. The sum of n is, I've got two different equations actually, one for infinite, which is this one, and one for finite. So here we go, sum of n, infinite, and finite. So the infinite one is a1, 1 minus r to the n, all over 1 minus r. And again, r is still negative 1/2. N is the sum of how many terms you're going to find. If it's finite, say that's 10, for example. And then a1 is the first term. And for infinite, this part just goes away, because r to the n, oh, by the way, if it's infinite, the absolute value of r has to be less than 1. Finite, it could be either one. It could be anything. Okay, so if r is less than 1, this part goes away. If you guys, you go to infinity, and it is simply not really n anymore because it's infinite. a1 over 1 minus r. All right, let me apply this to this. So first of all, I'm going to find the sum of the first 4 terms, which I can see is just 8 minus 4. 4 plus 2 is 6. It's just 5. I'll show you get 5. So it's a finite one if I'm doing the first 4 terms, so I'm going to use this one. A1 is 8. 1 minus negative 1/2 to the n, which is 4 over 1 minus negative 1/2. That doesn't really look like it's going to give you 5 particularly, but it will. Let me simplify down here. 8. That negative 1/2 to the 4th is 1/16. So this is 1 minus 1/16. 1 minus minus 1/2 is 1 plus 1/2, or 3/2. Still doesn't look like it's going to give you 5. But I'm going to convert that to 16 over 16. And that gives me 15 over 16 times 8 divided by 3/2. This cancel this and you get 2, or 15 over 2 divided by 3 over 2. Flip and multiply, and you get 15 over 3, or 5. There we go. You will see you get quite messy numbers when you do this, because this is always going to be, this term here is going to be a fraction largely. Then you're just going to be doing 1 minus that, and then you're going to divide it by some other fraction if it's a declining, a declining geometric sequence or series. All right, that's S4. Now I'm going to do the infinite series that we have right there. So if I go forever, my sum is a lot easier to do. It's just 8, A1 over 1 minus minus 1/2, 8 over 3/2, or 8, flip and multiply, times 2/3, or 16/3. That's if I went on forever. All right, that's basically it. Let me do one more thing for sequence and series, which is summation notation. It's not really to do with this. Actually, I'll do this one. Use this as an example. Summation notation is just a shorthand way of writing this sequence. So I write it as big S in Greek, which stands for sum. I start with a number, starting point, let's say 1. And I go to, I don't know how many terms. In this case, let's say I'm going forever and I want to actually give this, but let's say to n generally. And then I have some formula, a sub n. That's the summation notation. That just means A1 plus A2. This is the starting point. This is the ending point. And it can be infinity if I want it to be. Ending point. So ending point, starting point. And this will be my explicit formula. So in the case of this one, example, I'm starting from 1. I'm going to infinity. And my equation, remember, was A1, which is 8, R, which is negative 1/2, to the n minus 1. That's a representation of that. Or I would say it was truncated, or only to 4th term, let's say. I would just change that top number to 4 instead of infinity. I equals 1, 2, 4. This should actually be not n, rather, but I. 8 to the negative 1/2 to the I minus 1. Sorry, go back and change that if you didn't. This should be I as well. Apologize. All right, that's summation notation. Just convert it if you get a problem like that. Convert it by giving the first few terms, and then let me give you an example as well of actually using it in action. So let's say I have the sum from I equals 1 to 4 of AI squared plus AI. Let's say that was my equation. What I would do in this case, this just means add them up, but I first have to get the terms. I put 1 in and get 1 squared plus 1. Then put 2 in and get 2 squared plus 2. Then put 3 in and get 3 squared plus 3. Then put 4 in and get 4 squared plus 4. And then I'm done. I put in 1, then 2, then 3, and I finally got to 4. This equals 1 plus 1, or 2. 4 plus 2, 6. 9 plus 3, 12. And 16 plus 4, 20. And now I add them up. 8, 20, 40. And that's my sum. All right, that's it. Good luck on the test tomorrow. Thanks.